Alright, let's look at the homework 7.5, 7.6, problem number 13. Alright, so we want to minimize distance squared, which is the quantity x minus 2 squared plus y squared plus z squared. Alright, and the constraint is x comma y comma z has to be on this cone, so it has to satisfy this equation. Right, so let's do that. Alright, so first thing is I don't like square root. I'm gonna just go ahead and square both sides. So we will get z squared is equal to x squared plus y squared. Alright, so then we can just subtract x squared and y squared. So we can write it as z squared minus x squared minus y squared is equal to 0. Right? So this guy right here, this is our, this is our g of x comma y comma z. So g of x comma y comma z. Alright. Then here, this is the function we want to maximize. So this is our, right? So this is our f of x comma y comma z. Alright. Alright, so let's formulate the capital F. So capital F is going to be simply quantity x minus 2 squared plus y squared plus z squared minus lambda times g, which is z squared minus x squared minus y squared. Right? Let's take the partial. So partial of capital F with respect to x is equal to 2 times quantity x minus 2. Right? Then a partial of this is negative 2x times negative lambda, so it's a plus 2x lambda, right? And set that equal to 0, right? Partial of capital F with respect to y would be 2y, right? Partial of that is negative 2y, so it's going to be positive 2y lambda. Set that equal to 0, right? Partial of f with respect to z would be, right, 2z and a minus 2z lambda is equal to 0, right? And partial of f with respect to lambda is going to be negative z squared minus x squared minus y squared, and this is equal to 0, right? Which is the same thing as the given constraint, so I'm going to just write it as z squared is equal to x squared plus y squared, right? So we have that. Alright, let's solve this. And the first thing is I'm going to just, everyone has 2, so divide through by 2. So I'm just going to cancel that and divide through by 2 and divide through by 2. Right? And I'm going to just solve the second and third equation first because it's easier to work with. So I'm going to factor out y. Then you have a 1 plus lambda is equal to 0. And the third equation, we can factor out z. Then you would have a 1 minus lambda is equal to 0. Right? Let's solve the second equation here. So there are two possibilities, either y equals 0 or lambda equals -1. All right, but if you look at this equation, right, so this is x minus 2 plus x lambda equals 0, right? If lambda equals -1, if you plug in -1 here, you have x minus x, so it cancels out. So you're left with -2 is equal to 0, which is never true, right? Which means that this guy cannot be the answer, right? Cannot satisfy all four equations, right? So we already know in this case y is equal to 0. So this is fixed, right? Then we have two possibilities here. If z is 0 or lambda equals 1, right? If z equals 0, right? So if you have y is already 0 and z is 0, right? So if z is 0 and y is 0, then of course x is going to be 0. So this is going to be one of the critical points, right? What if lambda equals 1, right? If the lambda equals 1, then you can just plug this lambda equals 1 here. So you're going to get, let's see, x plus x is 2x, right, minus 2 equals 0. So you can see that a factor of 2x minus 1 equals 0. So x equals 1, right? So which means that if you have lambda equals 1, x is 1, and y is always 0, right? Z value can be found by plugging in, let's see, x is already 1, so 1, y is 0. So z squared is equal to, maybe I'm going to look at this one. Z equals 1 squared plus 0 squared, so it's going to be 1. All right, so those are the critical numbers, critical points, and let's just find the distance, at these two different points. All right, so distance here is going to be, right, so if you plug in 0 here, so I have to add a square root here, right, you're going to get the 0 minus 2 squared is 4, plus 0 squared is 0, plus 0 squared is 0, which is square root of 4, which is 2, right? So this is at 0, 0, 0. But the distance at 1, 0, 1 would be square root of, right? 1 minus 2 squared would be just 1, right? Y is 0, so 0. And z is 1, so 1 squared is 1, which is going to be square root of 2, which is smaller than the 2. So this is going to be the minimum distance, right? So let's type it in. All right, so the distance we found with minimum distance would be a square root of 2, right? So let's check the answer. All right, it came back, and it looks like we got this one correctly. All right, that's it. I hope that this was clear.